Hi everyone, welcome again to Learning Math by Examples. Today we're going to cover the topic of exponents. So in definition, exponent means how many times a number multiplied by itself. As you see here, we have 8 to the power of 2, or it's called 8 squared. 2 is our exponent and 8 is our base. And this means that 8 should be multiplied to itself 2 times, which gives us 8 times 8 equal to 64. There's also another way to show exponents, and that's with this sign. So here we have 5 to the power of 3, meaning 5 must be multiplied to itself 3 times. This is also called cube. So this gives us 125. We also have negative exponents. And there's a rule with that. It says negative flip the positive. So anytime we have a negative exponent, we flip the number and it becomes positive. 8 to the power of negative 1 will be the same as 1 over 8 to the power of positive 1. There are also two special cases. First one is exponent of 1, which always be the same number. And second is the exponent of 0, which always results in 1. So any number to the power of 0 will give you 1. And these we need to remember to be able to solve the exponent problems. Let's look at our first example. 2 to the power of 4. So how we solve this? We just multiply 2 to itself 4 times. And that gives us 16. 8 to the power of negative 2. So as you remember, this is the same as 1 over 8 to the power of 2. And 8 to the power of 2 gives us 8 times 8. So this will come into 1 over 64. And if you put that in the calculator, you get an estimate number of 0.0156. Another example is asking 10 to the power of negative 3. Same thing, we just flip that and become positive 1 over 10 to the positive 3. And that's 1 over 10 times 10 times 10, 3 times. And that's 1 over 1,000. Now let's look at some more difficult examples. Here we have negative 2 to the power of 2. And if you pay attention, the negative 2 is in parentheses. So this means we want to multiply negative 2 to itself 2 times. And that's negative 2 times negative 2. It gives us positive 4. But what if we don't put the negative in the parentheses? So here, this is going to be different because here we only squaring number 2, not the negative. So we have to leave the negative outside and just multiply 2 by itself 2 times. And that will give us negative 4. So it's really important to put anything that we want to get to the power of the exponent in the parentheses. Let's look at another example. xy to the power of 2. This means xy times xy. But what if we write like this? Here x is not getting to the power of 2, only y is getting to the power of 2. So that will leave us with x times y, which is very different than the other one. Now let's look at some examples that discuss some more laws of exponents. Here we have a to the power of 2 times a to the power of 4. So here, if you see, our bases are the same. So this will follow a rule that says anytime the bases are the same, when they're multiplied to each other, the powers are going to be added. So this is the same as a to the power of 2 plus 4, which leaves us with a to the power of 6. And you can also, do this separately and get to the same thing. So a squared is a times a, so that's 2a. A to the power of 4 is a times a, like 4 times. So 4 times and 2 times, that becomes 6 times. So it's the same thing. here we have b to the power of 5 divided to b to the power of 3. So here, because they are divided, the rule says that you keep the base and then you just subtract the powers. So it's the same as b to the power of 5 minus 3, which is b squared. Again, if you write b to the power of 5 as 5 b's, multiple by each other, and then 3b in the denominator, the 3b in the denominator will cancel with 3b on the top, so we will be left with only 2b multiple to each other, which is the same as b squared. Another rule is when we have x to the power of 3, the whole thing to the power of 2. So when you have two exponents on top of each other, basically this is the same as x to the power of 2 times 3. And that means x to the power of 6. So now let's prove that. So let's just solve the x cubed first. So this means that x times x times x, right? So we have x times x times x squared. That means the base should be multiplied by itself 2 times. And this again will leave us with 6x multiplied to each other, which is the same as x, or x to the power of 6. Here we have ab to the power of 3. So this follows another rule called the rule of distribution. So this is the same as a to the power of 3 times b to the power of 3. And to prove that again, let's just multiply ab to itself 3 times, because that's what it means. So ab times ab times ab. And as you know, ab means a times b by itself. So we have a times b 3 times. Now, because these are all multiple to each other, we can just move all the a's to one side and b to one side, and that's not going to change anything. But this can show us that the first 3a multiple to each other, they represent a to the power of 3. And the 3b multiple to each other is the same as b to the power of 3. So that proves our point that, how ab in parentheses to the power of 3 will give us a to the power of 3 times b to the power of 3. There are very more examples on exponents, but I don't want to make a very long video here. That's why I'm going to cover especially the square root. I'll cover that in another video. But please let me know if you have any suggestion, any comments. That will help me to improve my videos and hopefully help you guys more with this. Thank you.